Here we will see core principles of component-based architecture. Basic principles of component-based architectures are solid principles, modularity, reusability, encapsulation, loose coupling and high cohesion. First we will see solid principles. With component-based architecture, components are well structured and maintainable. Single responsibility keeps the component focused. Open and closed functionality encourages extensibility, and interface segregation ensures clean APIs. This makes the system easier to evolve without breaking existing functionality. Then modularity. It divides application into small self-contained units, which makes the system more flexible as the developers can replace, update and scale individual modules without affecting the entire code base. It also supports parallel development across teams. Then encapsulation. Each component hides its internal logic and exposes only necessary interfaces. This abstraction reduces dependencies between components, minimizes side effects, and protects against unintended interaction, which is crucial for maintaining stability in large systems. Then reusability. Reusable components save development time and improve consistency. A well-designed components can be used across multiple projects or within different parts of the system, which makes standardization and reduce duplication of efforts. Then loose coupling. Components should interact with minimal dependencies to avoid ripple effects from changes. Loose coupling enables independent deployment and testing, which makes system more resilient and easier to scale. And high cohesion. A component's internal elements should work closely together toward a specific purpose. High cohesion improves maintainability and ensures that each component is understandable, testable, and functionally complete. Then types of components. Typically, components function only in one layer of an application, such as front-end versus back-end. However, various component architectures are reusable for different layers of applications. Different types of components are themes. It looks like a style sheet rules and grid definition where designers can position and size elements on the screen. Their purpose is to give a user consistent experience across all platforms and unify branding. Then widgets. Widgets are the component at lesser level. Widgets provide a reusable feature that adds to an application's functionality and can be considered components if they have their own set of definitions, such as parameters and variables. Then libraries. Libraries makes the system even better on large scale. Libraries provide an easy to use interface when wrapped around widgets or blocks. JavaScript is an example of library that offers an exceptional front-end experience. Then connectors. With connectors, you don't need to custom code to allow integration with other applications like PayPal, which reduces time, effort and errors. And plugins. Zapier is an example of plugin. Plugin allows for integration without writing custom code as well, which allows user to receive notification from other platforms like Salesforce or Slack. For instance, different steps to implement component-based architectures are: first, define component boundaries. That is, identify distinct functionalities in your system and group related features into logical components. Ensure each component has a single responsibility and communicates through clear, well-defined interfaces for better modularity and scalability. Design interfaces and contracts. Establish APIs or contracts for components to interact with each other. Use consistent naming, input-output specifications, and error handling conventions to ensure that components remain decoupled but the interoperable across different parts of the system. Then develop components independently. Build each component as a self-contained unit with its data, logic, and configuration, which allows teams to work in parallel and facilitate reuse across multiple projects or contexts. Then implement encapsulation and reusability. Encapsulate internal details to prevent tight coupling. Design components to be reusable by making them configurable, context agnostic, and free from complex dependencies on other parts of the system. Then test components in isolation. Use unit and integration tests to validate components' behavior independently. Mock external dependencies where possible to ensure components are reliable and easy to debug during system integration. Then integrate components seamlessly. Assemble these components using dependency injections, service registries, or orchestration layers to facilitate seamless integration and interoperability. Focus on ensuring compatibility between interfaces and handling versioning to avoid breaking changes during integration. And monitor and maintain components. Set up monitoring for components' health, performance, and failures. Establish a maintenance strategy to update, replace or scale components without impacting the rest of the system. Real-world examples of components are front-end UI libraries. React, Angular and Vue depend on component-based principles. Middleware and services, EJB, Cobra and .NET components are used for enterprise applications. And APIs and microservices. Modern distribution system deploys these components independently.